Today we will discuss some more questions, some more exercise questions from this chapter, pair of linear equations. So we start with this question. Find the value of k for which the given system has unique solution. So how can we do this? The first question. Yeah, we want to.
A1 by A2.
Yeah, A1 by A2. If the has a unique solution means the pair of linear equations are consistent. That means A1 by A2, A1 by A2 equal or not equal?
Not equal.
Not equal.
Not equal to B1 by B2. So for this equation to be consistent, that means has a unique solution. So we want to compare the A1 by A2 and B1 by B2. They should not be equal. So that means here A1 is 2 and A2 is k and B1 is 3 and B2 is minus 6. Okay, so we can write here 2 by k should be not equal to 3 by minus 6. 3 by minus 6. This is the statement. Okay, so for this from this we can solve for k. So if you reverse both fractions, what will you get? K by 2 is equal to k by 2 is equal to minus 6 by 3. Not equal, okay? And that means k by 2 is equal to, what is minus 6 by 3?
Minus 2.
Minus 2. Okay, so not equal, okay? So k not equal to 2 into minus 2. 2 into minus 4. Minus 4. So for this equation to be consistent, k cannot be minus 4. So k can be any other real number but except minus 4. Okay, for this pair of linear equation to be consistent or having a unique solution, the value of k, possible value is all real numbers except minus 4.
Sir,
yes.
We are asked to find the value of k now.
Yes. Value of k means k can be any real number. The answer you write up to here, k not equal to minus 4, then write a sentence, k can be any real number except minus 4. K can be 1. If k is 1, then definitely A1 by A2 not equal to B1 by B2. Okay, so similarly k can be any real number except minus 4. If k is minus 4, what will happen? If k is equal to minus 4, what will happen? 2 by k.
Not a unique point. Parallel.
Yeah, yes, they may be inconsistent or dependent. So here you ratios you check. 3 by minus 6, that is B1 by B2, that is 1 by minus 2. And 2 by k, that is A1 by A2. If k is minus 4, then this ratio will become 1 by minus 2, that is equal to the second ratio. It can be equal, right? It can be equal for unique solution. So if it can be equal, value of k cannot be minus 4. Okay. Okay, then the second question you try. What's the value of k? So no solution, right? So what's the relation of ratios of coefficients?
A1 by 2
A1 by 2 is equal to
C1 by
C1 by
not
B2.
equal to C1 by C2.
And is not equal to C1.
Not equal to C1 by C2. Okay. So you find out the value of k.
Minus 15, sir.
Minus 15. Okay.
Minus 15.
Minus 15. We can check it. Okay. So here you look. What is A1 by A2 here? A1
K by 6.
K by 6.
K by 6. Okay. So what is B1 by B2?
Minus
5
by
2.
B is minus 5, right? So A1 by A2 should be equal to B1 by B2. Okay, so K by 6 is equal to minus 5 by the B2 is 2. Okay, so from this equation you can find the value of k, right? So 6 you move to right side. So k is equal to minus 5 by 2 into 6. So you can cut 2 from 6. So 3 times 2 is 6. Yes, so minus 3 into 3 is minus 15. So k, the value of k is minus 15. When k is equal to minus 15, these ratios will be equal. Okay, so in that situation, so the third ratio is already here. 2/7 is not equal to this -5/2, right? 2/7. If you move both numbers to left side, then also the ratio will be 2/7. -2/-7 is again 2/7, right? So 2/7 is not equal to -5/2. So this condition is already there. So we don't want to do anything. Okay, but A1/A2 is equal to B1/B2. From this equation, we want to find the value of K. Okay, so we got value K is equal to -15. -15 is the solution. So such questions you can expect as a 2-mark question. A very short answer question. Okay, so you need to do only one step or two step, right? 1 or 2 steps enough. Okay. Before moving to next question, sometimes this relation here, the idea is in the first set of these questions, the idea is the A1/A2, the ratio, right? A1/A2 is equal to B1/B2 is equal to C1/C2, those ratios. Sometimes the question in the equation, pair of equation, check whether the pair of equations consistent or inconsistent or dependent. So we know how to check it, right? Consistent or inconsistent or dependent. And in some questions, I have seen a question like this: check whether the given equation is consistent or inconsistent only. Consistent or inconsistent. Then right here, consistent or inconsistent only. Not dependent is given though. Okay. In such case, what you have to do is simply the question is asked like simply a pair of equations will be given, a pair of equation 1 and 2 equations, and the question check no K. Okay, no K, there will be some number. Okay, and to check whether this equation, pair of equations, consistent or inconsistent. Dependent is not given though. Okay. So you can simply check just A1/A2 and B1/B2, B1/B2. If they are not equal, then the equations will be consistent. If they are not equal, then what we have studied is we want to check for C1/C2, and if C1/C2 is not equal, then we can say inconsistent. Otherwise, we'll say what?
Dependent.
Dependent. Okay, so here you want to check the C1/C2. Okay, C1/C2, you will check C1/C2. So if C1/C2, first one, suppose the first one is equal. Okay, I shall clear here. Okay. Okay. If you get such a question, what will you do is you will check A1/A2 equal or not equal to B1/B2. If it is not equal, then you will say the equation is consistent. Equation is, if the equation is not equal here, and then you want to check for C1/C2. Okay, if C1/C2 is not equal, what will you say?
Inconsistent.
Inconsistent. And in this case also, sometimes this may be equal. This may be equal. So what will you write there?
Inconsistent.
If the last one is also equal.
Dependent.
Dependent.
Dependent. But the question the only not dependent in the question. The question is check whether the given equation is consistent or inconsistent only.
Inconsistent.
So what will we write in the third case? That's the question. Okay?
Inconsistent.
So
Inconsistent.
by our definitions, the consistent, to be consistent, it should be not equal, and for to be inconsistent, the second one should be not equal. But here in this case, all the ratios are equal, and this is dependent. But in the question paper, there is no there's no dependent is given. Only check whether consistent, inconsistent. So in this case, what you have to write is you write the equation consists with infinite number of solutions. Okay. Here you don't write inconsistent. You write the equation consistent with infinite number of solutions. That means dependent. Okay. In such case, you write the equations are consistent with infinite number of solutions. So dependent, you can also write so. So we move to next question.